I'm going to do this video on a 446 pack setup. For this carburetor setup, customer sent it to me, is for a 1970 Roadrunner 446 pack manual transmission car. This is the center carburetor. It's got a list number of 4375. This is not really going to be a rebuild video. I'm going to show you the problems that you have with these Holleys, what you need to do to correct them, and you know, what to look for when you're buying these carburetors used off eBay or swap meets. First, I want to explain how the system, the idle, main systems, off idle systems all work, so then you can know why I'm talking about these problems that are going to occur and how it's going to affect the carburetor. We'll start out with the metering block. I'm going to start out with the idle system. Block is oriented like this on the body. This area here, your jet screw in here, which meted the fuel into this well. But if you look down here, there's some idle pickup tubes which extend up into this area here. They're like driven in. It's an assembly, and it has a passageway in here that extends down this tube here all the way, which corresponds to this hole here, which is going to feed your idle fuel into this chamber here, which is going to come down, and it goes into this hole, which also corresponds to the idle circuit, which is controlled by your idle air fuel screw. And then this is going to correspond to the body, which feeds down through the base plate, which I'll show you. So we have our idle fuel comes up through here, down here, fills up both of these slots, which transfers over. The second system we're going to talk about is the main metering system itself, which is a jet that's screwed in here. I have it off right now. The fuel will enter, being metered by the jet, into this large chamber. It's going to be pulled up and comes out this port, which matches the port on the body, which goes to the main metering nozzles. This port here is an emulsification port, which pulls air from the air horn down through these two holes here, which go right into the main metering area right here, where the fuel's coming up into the main nozzle. And what that's going to do is pull air into these chambers and emulsify the fuel, kind of give it that aerosol spray effect. So when it does come out to the nozzles, it's like aerated. They also have a small air bleed here that goes into the chamber here for the idle system, which kind of emulsifies the fuel in the little chamber first before it comes out this hole. Now the idle system also has an emulsification system that corresponds to the body into the top of the air horn, which will allow air to emulsify with the fuel that's coming from this port down, and they'll aerate it before it even gets, you know, into the base plate system. I'm trying not to get redundant here. I've had to shoot a couple of these frames different, so if you see one that talks about the same thing, I really don't know how to edit these programs that well, so you'll have to bear with me. This port here is for your accelerator pump system. This hole here corresponds to the block, feeds fuel through here, comes up to your squirter. You have a pintle seat in here, and then you have your squirters on top. So that's going to, you know, go right through here, out, and give you your accelerator pump shot into the carburetor. This block picks up its feed on this side from the fuel bowl. See the hole? It's going to pump the fuel up that channel and out that hole into the system. The fuel bowl, if you can see here, has an outlet. Your accelerator pump fits in here. Has a spring, diaphragm, and the pump arm. So what it's going to do is when it pushes the fuel, it's going to come out that hole under pressure into your accelerator pump system. This also incorporates a check ball in here. You got to make sure that that's clean and it'll seat, because what that does is allow this chamber to fill with fuel through this hole here. It fills up. When the accelerator pump starts to put outward pressure, the check ball seals and only allows fuel to come out this hole. So you got to make sure that this ball is clean and sealing. Otherwise you're going to start pushing fuel back into your bowl, and it's going to affect how much fuel is coming out the discharge hole. You got to make sure all that stuff's clean and that needle or that ball is working correctly. The next system we'll talk about is the power valve. What the power valve does is it screws into here in the metering block, got a gasket, and power valve is rated at so certain amount of inches of mercury before it will allow itself to open. That means that the vacuum these are rated at 6.5 inches of mercury, which means that the vacuum in the motor has to drop below 6.5 inches for the power valve to open. And what it's going to do when it opens, let's see if you see there, it's got two small holes here and here, and when it opens it allows fuel from the main bowl through here. When it's open, for the fuel to come through here and through these little slots, and it will feed extra fuel bypassing the jets right into the well. Extra fuel. This port here is ported vacuum, which corresponds all the way down to through the body to the base plate, and it's a slot that's just above the throttle blades. So when the throttle blades expose that slot, it'll start pulling a vacuum off of here, and this one here goes to the distributor for the vacuum advance. So I think we've covered all the circuits on the metering plate itself. We'll see how they correspond to the body. And here we go. The main system is feeding these two big holes here, which go directly to the nozzles. This is your idle feed, which is going to go all the way down to feed these two holes here. Transition, idle, restriction, your needle. Same thing on the other side. Air bleed for the main metering system. As I showed you, air bleed for the idle system. They'll correspond to these holes in the bottom. Here is off transition slot corresponding to the base, idle corresponding to the base. This one here is the ported vacuum slot I was telling you about. Same way on this side. Goes down to the base plate, and then here we go again. Here's our idle slot, our idle hole that allows the fuel below the throttle blades, both sides. You see them. The inner hole is your transition slot. You can see the slot here extends down. As that throttle opens up, it starts exposing more of that transition slot, which allows you to pull more fuel to transition you between idle to off idle to the main circuit. Here's that ported vacuum slot I was telling you about. You will not start pulling vacuum from that port until it's exposed to the incoming air. Idle adjustment screw over here. You know, there's your arm assembly and stuff for the accelerator pump. This is direct manifold vacuum port. Goes to the PVC. This is direct manifold vacuum port that goes to the choke pull-off assembly. Okay, now that we've kind of went over the systems, how they work, this is going to correspond to how important what I'm going to tell you is on these Holley carburetors. And this carries through pretty much through all Holleys. One of the biggest problems you're going to encounter with these older carburetors is a warped metering plate, which I'm talking about. The face of this metering block has wound up arcing like this direction. So what happens is you're pulling all your tension on the corners here, drawing this down to the gasket, and the center will not seal. All your passages here are not sealing. And what's going to happen is if you don't get a seal around this area here, you're going to wind up pulling fuel from this air bleed system, and possibly even fuel all the way from the idle system all the way across into this vacuum only area. Because you got to remember, even though this is an air bleed system only, the fuel is going to back up to fuel level, which is going to be somewhere around here, and the fuel is going to actually be going into this port. So you're going to have fuel actually sitting in this air bleed system. So if this is leaking here, you're going to pull fuel over. Because I'll show you this power valve, when it's screwed in, I'm going to take the gasket off. You know, the gasket seals it. Screw it down. It's sealed here, and there's fuel on this side. You know, there's fuel all in this area because it's where the bowl is maintaining the fuel level. So what happens is this body here, you got to think of this whole area in here as a vacuum chamber, which is supplied by this hole, which corresponds to a hole in the base plate that draws direct manifold vacuum. So when the motor starts, you're pulling vacuum through the hole. There's a hole here where I'm pointing to that comes up, and it supplies vacuum to this chamber, which in turn applies vacuum to the back of the power valve, which is going to close it. Remember, this is closed until you get below 6.5 inches of mercury vacuum. Then it'll open. So right now you can see what I'm talking about, where your problem is going to be. If that metering plate is leaking, you are going to pull raw fuel into the vacuum chamber, which in turn is going to be feeding raw fuel into the engine, unmetered fuel. It's going to cause all kinds of idle problems. And also the warp will affect the feed for the accelerator pump, and you'll pull fuel from your accelerator pump system into the main well also. The 6-pack is kind of unique. If you notice, they've got this vacuum tit coming off of here, and that vacuum tit controls the outboard carburetors, and where it picks its vacuum up from, get a wire, This is going to go all the way through into here, and way up at the top there's a port here. You see where my wire is? It's right here. It's way at the top of the carb. So what happens is when the primaries are opening up, the air is really starting to come through here. It's going to come by that port and create a vacuum on this tube. In turn, this tube's going to apply vacuum to the rear pods and start opening them. These faces also warp, and they primarily warp at these thinner areas here, here, and here. Not so much here because it's all this beef for this extra vacuum. Now, this all has to be filed, or if you got access to a milling machine, it has to be flat. When you start running your file, this is a difficult one to file because you got to get a smaller width file because you want to keep going all ways when you're hand filing them. And then when you're going to see right away how high these spots are, and your file is not even shining up these areas around your port, especially this whole perimeter around your vacuum chamber. That all has to be sealed 100%. This is the big problem you run into with Holleys, and especially 6-pack setups not idling correctly. Off idle is no good. And then also an overlooked problem is the base of the casting will warp also. These are easier to file because you can run your file straight across. You want to use a wide, fine file. Keep working back and forth different directions, and when you start running that file, you see your file's not hitting none of these ports or shining up these areas. So what that means is it's leaking, it's pulling air into your idle system, and what that's going to do is allow air to come in at this point and not pull enough vacuum at the upper end to pull your fuel down. Really overlooked. Same thing on 4-barrel Holleys and stuff. When you start filing the bottom of those castings, you're going to see what I'm talking about. These areas have to be flat. Now on the base plates, because they are aluminum, they won't take a shape like that normally, but I do run a file across this and the base. These are little roll pins, they just pull out. You can hand file this and you'll see them clean up right away. Never usually an issue. The reason why this casting material is a Zamac 3 casting material, predominantly zinc, has some aluminum and some other crap in there. Its melting point is 380 something degrees. So you can see why the under the hood temperature gets so high. You get up to 280 degrees, maybe closing in on 300 just after you turn a hot engine off. Now what happens is because you have tension pulling against here, it's very easy for the casting to start taking a shape towards the tension, and that's why these faces pull, and that's why the metering blocks warp. Really the only cure for these metering blocks is to replace them. Okay, this here is the replacement block, and right away you're going to see a difference in how they've, and this is the replacement for the new Holley 6-pack setups they sell. You can see how they've changed to help reduce this warpage problem. If you can see all this ribbing that they've cast in here to help keep these blocks from bowing. They wouldn't put that in there if they didn't know they had a problem, because you can see the absence of that ribbing in the original one. Now maybe these will not warp, I really don't know. Time is a test for them, to see if they do warp out. I'm going to just say, for instance, that your metering block was not warped. Okay, so the metering block's not warped, but you have to clean this. And where they're going to fail and get plugged up is that tube I showed you down here that goes up into this assembly here, which feeds over. Very small orifices, very small. The way you can clean them, the way I clean them, there's some guys says that they can take these out of here. I've done a couple on some core metering blocks and destroyed them trying to get them out of here. In the exit passage here, carburetor cleaner straw fits perfect in here, and you can keep spraying that carburetor cleaner in there, and what you want to see is a nice spray pattern coming right out the end of these tubes. And then you can pretty much bet that that passage is all clean in there, because basically what the tubes look like, I was just, you can see this diagram drawn here. This is at the very top of the metering block. This goes down into that upper chamber I told you that feeds over, and this is the pickup tube. You can see how small that is. Comes up, comes into this chamber, out these two holes, there's one on each side that kind of fill this void, and that allows the fuel to pull into the, fills this void here and pulls into the system. So I can show you how important, if this all gets gummed up, you can't pick up any idle fuel, so you have to get in there and clean it. Don't go in there with any blasting media, because you can see how small that area it is. You can get that fouled up with blasting media and it's be almost impossible to get it out. If you notice on this new plate here, you know, I had to replate the thing. I've masked off all these areas, so you know I didn't get any media blast in there, because I had to blast them in order for the plating to take and the dichromate finish. Next thing we'll talk about the fuel bowls. You know, you're buying these sets used. First thing you want to check for is that the needle and seat threads assembly are not stripped. I got an old bowl here. If you'll look in there, you know, there's not a lot of threads in there because the fuel has to also come up in that area. And the reason these threads get stripped is this screw here is a locking screw, has a gasket on the bottom of it. This is your adjusting nut and your lower gasket. And the adjusting nut is, you can push the needle down or back, bring it up, raising the fuel level, or pushing it down lowers the fuel level. And what happens is when you put these gaskets on, you want to adjust this fuel level so it comes to the bottom of your sight plug. You need to lube these gaskets with some like dielectric grease or Vaseline, because you got to remember you got a nut spinning on here, and it's best to loosen this all up and make sure you break this free, this whole assembly is free, lube them up, because you're going to make your fuel adjustments. What happens is people are loosening the screws, the gasket is sticking, they crank on this, they tear the gasket, and now it's leaking fuel from around here or at the upper side. So what the natural thing is, keep tightening. Yeah, let's crank it down some more, it'll stop the leak. And they put so much cranking pressure on here, they're pulling against these threads on the needle assembly, you know, they're pulling it up, and they pull the threads. And that's basically how the threads get stripped. So anytime you got a gasket that a screw turns on, you want to lube them up with some Vaseline or dielectric grease so they can slide around. Same thing with the power valve, because the power valve, you're screwing it in. You want to lube that gasket up with some dielectric grease or Vaseline. You want to make sure that it's in its proper seat on the power valve, because it can dance out left or right, and then you will not be getting a seal there. You'll be allowing fuel to go in. You see that just got that little shelf. and then by putting that dielectric grease or whatever, it'll stick real nice, so it doesn't, you know, get off on you a little bit like that, you know, dance over and start leaking. So these are the issues you're going to run into. So you bought these carburetors used on eBay or swap meet, and you get home, and now we're just strictly talking about the center carb here. First thing that's wrong with this one, warp metering block. You have to buy a new one, $50. Had the wrong jets in it. Supposed to, manual transmission car for this year is supposed to be 64 jets. I think there was 66 or 5s in here. You know, $10 right there. This bowl was in good shape, no pulled threads. But if you had to replace this, you know, first you got to find one. Probably looking at about $60, $70. And also check your fuel threads here on your inlet. Make sure they're not boogered up. You don't usually find too many problems there, but that's all stuff you check. So you can see how these costs start adding up on these carburetors. Now the way I check these metering blocks to make sure that they're sealing is, let me get my Mighty Vac out. Now I'm going to show you how I use the old Mighty Vac vacuum gauge deal. If you guys don't own one of these, this is a great tool. It's used on many different applications. But you know, they give you all kinds of little adapters and stuff. And what I'll do is when you know, I bolt up, you know, I got my gasket, bowl gasket, everything's assembled. I bolt the bowl up, tighten everything up, and this is before I have it mounted to the base plate. You could have it mounted to the base plate and go into the port in the bottom, but right now I want to make sure that the I'll recheck that after I check this system to make sure that I'm not leaking any vacuum at the base plate. So right now we're just checking the body. So I'll put my vacuum titty in there, it seals, and you know, I got my bowl assembly, everything's together, tightened up, just like it's ready to be on the car. And I'm going to pull vacuum into this chamber. This chamber has to hold vacuum. You know, I'll pull 20 inches up on it and sit there and watch it, and it can't bleed off. If it's bleeding off, you've got a leak, and you have to fix the leak. Another tip I'm going to tell you guys is the customer supplied the rebuild kits for this. I'm going to tell you right out of the gate, anytime you're doing these Holleys and stuff, buy Holley parts. I don't know, they've got all kinds of Chinamen making this crap, and most of it's shit. And the prime example these black gaskets that came with the kit. The original gaskets, because somebody had rebuilt this carburetor. Were the blue reusable ones. They say Holley on them. I put this gasket, the black gaskets on. I ran my vacuum test, and the vacuum would pull up to about 10 inches, was as far as I can do, and then bleed off right away. And so I'm thinking, you know, maybe I've got a pinhole in the vacuum chamber area, or the brand new metering block's got a warp, which I checked it and it was nice and flat. So I said, well, and all I had was the old original gaskets. So I took the old original, because these are reusable. I put that in, put the bowl assembly back together, pulled 20 inches of vacuum, and it held perfect. Now I have ordered a new set of gaskets for this. I'm not going to reuse these old ones. But you can also see on there is it puts a nice indentation pattern of all the chambers on there. So it'll show you that you're sealing on there. These black gaskets here, they're like a brick. They have no give. It's like a brick. I can just feel it. The difference between this and the Holley gasket, you know, just pushing on them. So when you're doing these, buy Holley gaskets. Even though you're tempted, oh yeah, this guy's got a kit for 25 or 30 bucks per carburetor, and you know the Holley kit is 40 or 50. Well, there's a reason. It's a get what you pay for world. And also, what comes with the old Mighty Vac is one of these. And you should always check these power valves. Don't take it for granted that they work. And I'll pull a vacuum on this. See it pulled down. And I'm holding vacuum. So I know the power valve is good. These also came in the kit, but guess what? I ordered a new Holley power valve made by Holley. Actually, these aren't even marked what their vacuum is, and I don't trust them. So we ordered a new one of those. The rest of the gaskets seemed like they were all right. The base gasket, because it's a different material from this, and stuff. So I'm gonna go ahead and use those. The little corks and all that go in here for your idle. That stuff all seemed fine. And because the customer already bought it, I opened the packs up, not knowing that these gaskets were crap. Otherwise we would have just sent all 3 kits back and we would have bought Holley kits. But this is basically covering problems you're going to run into buying these Holley 6-pack carburetors, because they're very expensive to find the original numbers one. And this is probably what you're going to run into if you ever see these bodies sitting so low. They've got a correct number for your car, on eBay, and the guy wants so much. Well, there's a reason why that body is there all by itself. Stripped. It's either got a crack somewhere in the casting, it's got stripped screws, for the bowls. Something's up with it. So pretty much stay away from that kind of stuff. The next we're going to do is we're going to move on to the end carburetors, which are a whole nother story, and we'll continue on. I'm going to do this little segment as a plug-in, something I forgot in the videos. On the base plate, we were talking about the transition slot. You want to make sure that you don't have anything larger than a nice square in this transition slot when your idle's set. If your idle has to be open too much to make the car run, you're going to wind up pulling most of your fuel through the transition slot, and you'll have no control over the idle air fuel mixtures in the block. If you have to open the throttles any wider than that, you got some kind of other problem that you need to take care of. Also, when I was explaining how the bowls get stripped, just so you weren't confused, I might not have been explaining it right, but it's not the jam nut that over torques the needle seat assembly. It's the locking screw on the top, this one here, because it screws into the jet or the needle seat assembly, and when you start cranking this, you're pulling, because you can see that this square nut, the needle will pass right up through it. That's where the pressure is coming from to actually over torque and pull against the threads on the needle seat assembly, and will pull the threads out of your bowl.